Hello, we are Team CW1 of the Serious Games and AI course. My name is Gabriel Han and I was the Agile leader and worked on RL and data analysis.
My name is Willie and I was in charge of UI design and machine learning experimentation.
I'm Ronak and I did programming and data analysis.
I'm Kaya and I worked on UI and data analysis.
Hi, my name is Shrikar and I did the sound design as a part of the UI, and I also created different custom maps for the RL training.
So the main background for our project comes from exploring the ethical side of serious games. So specifically, we wanted to know what we can do to move away from instrumental conversions. So a very easy way to think about this would be the thought experiment of a paperclip machine, where an AI's uncontrollable reward function will cause it to distort basic rules of morality in search of a goal to make paperclips. So our group was very interested in reconciling this need for ethics with the existing need for intelligent systems to actually get things done. So given that we're very interested in this area of AI safety, we decided to investigate reward hijacking as a means of accomplishing it. And given that there's really no widely accepted solution yet, we wanted to explore this new avenue.
We thought on how AI was implemented in real-life products in which they had to make decisions, such as self-driving cars or medical technology. In the prerequisite course, a discussion topic was based on the survey results of a trolley problem simulation. The scenario given was always fairly simple. Should a self-driving car doom its passengers to save pedestrians, or vice versa? The makeup of the respective populations varied in order to gauge which demographics were prioritized by the individual. In this serious game, we were given a similar ultimatum: rescuing pedestrians with different values they may have in different perspectives to see how a population might act or support in a high-stress situation. We wanted to compare the moral inclinations of human players with those of AI, which would further be reinforced with different reward systems to see if that affected the results of these decisions. The goal of the zombie simulation, if applied to real life, would be to have an autonomous vehicle that can make the most popular decisions to act as an emergency response. The research question we decided on was, what effect do moral policies have on scoring performance? We hypothesized that AI would probably choose the optimal figure to save or sacrifice purely depending on which action gained more points or lost less. Humans, on the other hand, could choose less logical moves depending on their emotional response to the acts committed in-game.
Now, the game. At the beginning of our project, we were provided with the following base game. In this game, the goal is to earn the maximum attainable score with points given or lost for certain actions as shown below. The energy dictates how long the game will last, and you lose once you run out of energy, which is lost through any movement or additional damage in some cases. However, we went on to add many developments to our game in order to test human and AI behavior. The key development for this was the implementation of different moral attributes. We added 3 key modifications: social value, age, and gender. For each of these modifications, we created 2 different structures to test how both humans and AI would react to different point systems. For example, one age structure rewarded you 15 points for saving the perception of an old person, but only 5 points for saving a young person, even though there were twice as many young people on the map. Vice versa, the other age structure rewarded you 5 points for saving an old person, but 15 points for saving a young person. The same contrast was made between the human perception of the other moral attributes. The point of this was to test the limits of the AI. For example, would it kill 2 young people to save 1 old person for 5 more points to its score, or would it prioritize saving lives? Similarly, we were also curious to see if these social structures affected the behavior of humans and if they hesitated more. To make these changes easier for the user, we built the following legend.
An important aspect of having all of these different attributes is clearly communicating to players what the conditions of their current play state are. So unlike the base game, there's not as much ambiguity about what the particular pedestrian or injured agent is and what attributes they hold. So with our marking system, which clearly displays a graphic above an agent's head, the game can communicate who an injured person is versus a pedestrian, and the consequence of what going to one person are over another. So this way, the simulation will give you more than enough information to make strategic decisions consistently. This tenet of accessibility also extended to our UI design philosophy, where we intended to make things as engaging and interactive and readable as possible. So for one thing, we replaced the traditional 2D grid with isometric tiles in addition to adding the aforementioned agent sprites. And we also added some basic but very much needed quality of life additions like a battery indicator, a live score counter, and sound effects, all to make for just a more engaging and ultimately more realistic medical simulation environment. And obviously, if we just look at a side-by-side comparison compared to the base game, the difference becomes quite obvious. we're really very satisfied with the improved accessibility and interpretability that our UI modification brings.
Other important changes implemented included code written for the logic and fine details behind the game. In an effort to simplify our game for the RL agent, we removed the turning mechanism so that the ambulance can navigate with basic arrow key movements, built custom maps to reduce the state space, and experimented with various reward structures. For example, we gave points for picking up a person, an additional reward for completing a multi-step task. In an earlier version, we also experimented with providing points for moving to valid squares on the map and taking away points for running into a wall and damaging the ambulance. This helped the initial RL learn to explore and move around better. Lastly, we changed the sprite probabilities and added sound effects for a more engaging experience.
The same UI design that was described before, and each time you have the point counter increasing for every single time you rescue a person by bringing them back to the hospital, and for every single time you pick up a human. If you end up running over humans, you will end up losing points, which is very bad for your score. You also don't want to go into the mud or into the fire as well, because that will also lead to a negative impact.
Part 2. The machine. The machine learning model we used was a deep Q network, a type of reinforcement learning. We hope to provide the machine with different states and rewards to create a Q table and allow it to adapt to new environments by incorporating a neural network. While testing, we varied our architecture between 3 to 5 layers and 200 to 500 nodes, depending on the layer. We used dense layers with a ReLU activation function, but we had experimented with some others as well. We also added a batch normalization layer which helped speed up the initial learning and looked into using humans to jumpstart the RL. After a while, we realized that our RL agent always chose the same moves, even during training. So it was unable to explore deep into different states, pushing us to create an entirely new agent with TensorFlow DQN agent and Pi environment in hopes of better customizing the policies and step functions.
We then started our data collection, first with human data but a limited sample size from a variety of demographics to make the best possible conclusions. First, we examined the differences in data between the two different route structures with human play. One structure gave more points for saving poor people and the other gave more points for saving rich people. To maintain realism, there were twice as many poor people than rich people on average. We reached the conclusion that poor people were always prioritized despite their reward structures due to a higher probability of a poor person in proximity. As seen through this graph, poor people were always saved more than rich people despite their reward structure. In general, our human test subjects attempted to save as many lives as possible through first saving those near them. Consequently, on average, more poor people were saved per game than rich people. Nonetheless, as shown through the average data on lives and deaths, there is a noticeable difference with the reward structure change with the averages, as when more points were given for rich people, more rich people were saved on average. But in the end, lives were given the utmost value, while deaths were almost always avoided.
We then proceeded to test our attributes with regards to age structures. One structure gave more points for saving old people, while the other gave more points for saving the young. To maintain realism, there were twice as many young people generated as old people on each map. On average, young people were saved more than old people due to the probabilities showing the priority for saving lives shown through this frequency graph. As shown with the average data, there is still a noticeable gap due to the reward structure, with the average changing based on points but the overall trend remaining the same. Deaths were mainly minimized in Structure 1, but in Structure 2, young people were killed more than usual. The death value in Structure 2 was a major outlier in our data, yet the trend seen with wealth structures remained.
Finally, we applied our gender attributes. One structure gave us more points for saving females, the other gave us more points for saving males. To maintain realism, there is an equal number of males and females on average. With equal distributions of both, more attention was given to saving whichever gender carried more points, as shown through the shifts in the histogram. Yet, the main focus was on saving lives and minimizing death, with nearly zero death averages as shown on the graphs. On the other hand, the RL prioritized not killing people to prevent itself from getting negative points.
So what does this all mean? From watching participants play, we noticed they were mainly concerned with bringing people to hospitals as it was the main objective of the game, not paying too much attention to the attributes of the people. They usually prioritized the people in the vicinity of the ambulance as it would be most efficient short-term with limited turns. However, when faced with two different characters similar distance away, people usually chose the character which provided more points. When taking into account probability of appearance, each character was saved more when they were prioritized. Since the map was seen from above, the attributes were not as clear to the player, and the player did not have as much sentiment for the various characters. So after all of our modifications, was our hypothesis correct? We collected data from each game type of varying reward structures and determined it was partially right. While the different reward structures definitely made a change in people's decision, it was not the only factor, and more data would be needed to verify significant result. People usually prioritize efficiency, and whichever character provided more points. This indicates that people were not emotionally attached to the characters, but had learned at the back of their mind to save the character with more points. In real life, this would be probably similar, because while driving around a city full of injured people, one would look just to save the dying souls in front of them, without being able to see whether they are rich or not. However, small visual cues may change people's perspective while choosing between two people depending on their own moral values.
With more time, our dataset would have included a wider range of test players. This would result in better interpretation of how morals are distributed and showcase the differences in human behavior. Adding empathy into the game would allow the player to be immersed into the game, which may lead to different results. Finally, by making the AI more advanced, this may cause data that shows how a machine is influenced by a point-based system even more than it already is right now.
There are also a few more things we would add to the game for future use with more time. For a greater sense of urgency and realism in the UI, we would model a realistic field of view and also have infection rates increase as time progressed. We would also heavily focus on getting more insight with our AI for better machine comparison and also embed more empathy to see if there's a more visceral effect to actions for humans.
The main conclusion is, human players didn't focus on morality as much as we expected. It was observed that they stuck to a more logical calculation of who was closest to them to save. Points had an effect when having to choose between two lives that could easily be saved in terms of proximity or terrain. When given a goal, they strive to achieve that specifically. From interpreting the data, you can see that the groups prioritized were rescued more depending on each value structure. And it should be mentioned again that our game was not realistic in the passage of time or perspective of a vehicle and its movement across the map. We chose to show ultimatums in simple ways to determine the patterns of moral choice. In addition, there was no duress to affect the players as there would have been in an actual emergency state, which may have altered the reality of the results.